And before I get started, I wanted to ask you guys if you would consider helping us name our rover. So the planetarium just got a rover, and there's a contest to name it. So if you look on the Facebook page, then you'll be able to help name it. Okay, so gravity. So what is gravity? Gravity is the force that keeps us glued down to the Earth. Sometimes I think that's a little annoying because I think it would be nice to be able to fly. But it's also really helpful because it's what keeps the Earth spinning around the sun, and the sun is spinning around everything else in the solar system. So gravity is kind of mysterious, but essentially what it boils down to is that objects with mass are attracted to each other. So the Earth is more massive than us, and that's why it's pulling us down. The sun is more massive than the Earth, and that's why it's pulling the Earth along with it, and so on. So that's what our experiment is going to do. And one way to think about gravity is to think about space-time. And space-time is just space and time connected together. So we're actually going to make space-time. Rufus is going to go back in his perch and watch. So there's a lot of ways you can make space-time. This is one way I did it. So what you really need is stretchy fabric. And I cut up, this is old pair of leggings and a quilting hoop, and this is our space-time. And so what's important in your experiment is that the space-time remains flat, like so. And this is important because if you put something massive in it, I got this is the most massive thing I could find, and you can see how it's stretching space-time. And so as the space-time gets stretched, then things are drawn in towards it. Okay, so I have a different space-time setup, but if you're doing this at home, you can use pretty much any kind of stretchy fabric that's taut like that. If you have like a big trampoline or a little trampoline, or even the stretchy fabric in a hoop, or it could be a stretchy blanket that people are holding. There's a lot of options here. For this demo, I actually cut up an old swimsuit here, and then I attached hair ties to it and stretched it out on the chair. So it's a little bit like a trampoline, so that's what I'll be using for space-time. And then I have a bunch of planets and so on. So I don't have a lot of round things around the house, so I had to get a little bit creative. So I found a coconut, a pear, an orange, an onion, a kiwifruit, a tomatillo, a ball of yarn, and then some smaller stuff. I have potatoes, these limes, and then I think marbles would be really good for this, but I lost all of my marbles. I did pull this little round thing off of some wind chimes, and then I found these little ball bearings and little round pieces of candy. So that's what we need for the experiment. So pretty much stretchy fabric, hold tight, and then round things of different weights. And then the other thing I did, because this is an experiment, so we want to know about all the stuff we're going to be using today. So I used a little scale and I weighed everything. So the exact numbers don't matter. It's more what is more heavier than the other stuff, right? So when I weighed them, the coconut weighed the most. Next up was the pear, was the next most heavy thing. Then the onion, then the orange, and then the kiwi. Tomatillo weighed less than the kiwi, and then the potatoes and the limes were all kind of weighed less, and then like the tinfoil ball and this little ball bearing actually weigh the same amount, which is interesting. All right. So I am going to hook my computer into these chairs because I need my hands free for the experiment. So bear with me just 1 second. Okay. If I hold this up, and if I put this in here, you should be able to see space-time warping. All right, how does that look, Shannon? Okay, so what's important here, so this is, you can think about this is our black hole warping space-time pretty heavily. And if I take my little marble and I just drop it into the center, what do you think is going to happen? So remember that this weighs maybe at least 10 times more than this does. I weighed this at, oh boy, this is probably 100 times more massive. This is 1,000 grams. I weighed this in at about 10 grams. So if I just drop it in, what do you think is going to happen? You can guess. You don't have to say it out loud, you can just guess. So it gets attracted towards the center just by dropping it. So now we're going to throw it kind of hard. Oops, a little harder. So that one escaped and ran off. So what it matters is when you're being drawn into something, what matters is your mass. And not only just your mass, like the relative masses, but also the speed of things. Because if I'm not throwing it very hard, it gets pulled in. But there is a speed at which I can throw it where it escapes. But there's also a little kind of intermediate speed where it'll go around a bit. So it's not perfect because this is not like a nice round circular shape. So it kind of has a weird orbit. So if you're trying this at home, you should try to make orbits with your spacetime. Ooh, that was a good one. Look at that. Circling in. An unstable orbit. So this is kind of like the Earth's orbit around the sun too, right? It's this nice circular shape. Another thing that's interesting about gravity. So gravity has to do, like what it's saying is that everything with a mass exerts force on each other. So the Earth is exerting a force on you, but you're also exerting a force back on the Earth. And because you're so much less massive than the Earth, it doesn't really make a difference. But the same thing applies for the sun and the planets. So the sun is what's pulling all the planets around, but all of the planets are actually pulling back on the sun, and they can make the sun wobble a little bit. And we can try that with a couple different objects in our experiment. So I'm going to try the coconut and the pear because these two are fairly similar in weight. So we have the coconut in the middle, and if I roll the pear in, you can see it's kind of hard because I don't have a huge space here, but the pear disrupts the coconut a little bit. So that's one example. The other thing I wanted to try, I'm going to put this large weight back in there. And I want to start from the least massive object and work our way up to the most massive object. So I'm going to start with my little ball bearing. And that doesn't impact it at all, right? It just kind of, we can make it go wee, like that, but it eventually falls in towards the center. So if we go again with the marble, we know what the marble does. Let's try this big aluminum foil ball. Oh, that was a pretty good one. Okay, let's try the lime. Oop, lime's trying to escape. I'm throwing it too fast. It's a little hard, like I said, because I have weird shapes of objects, but if you have some nice circular stuff at home. Let's try a potato. Oh, potatoes are pretty good for this. Let's try this piece of candy. Alright, now, so the kiwi fruit, I'm not sure how well that's going to work, because it's a weird shape, but we should definitely try it. Oh, that worked better than I thought. Alright, and then the tomatillo. This should be pretty good. I might have to take the husk off. Okay, so here's the tomatillo. That's a pretty weird planet, right? Okay, now... Here is my ball of yarn. It's also a weird shape. So the ball of yarn, I forgot to tell you guys how much it weighed, but it weighs about the same as the tomatillo. So it's, even though it's a lot bigger than the tomatillo, it weighs about the same amount. We'll just hold them up together for comparison. So these two weigh about the same. So here's the tomatillo again, that works pretty nicely. And the ball of yarn is not behaving, so we'll not use that anymore. Next up is the orange. So you can see we're almost getting to a point where the orange is disrupting the weight just a little bit. So this is useful information, because the other question I was kind of wondering about is how massive, like what combinations of masses do you need to get them to disrupt like this? So seems like the orange is working pretty well. All right, next up is the onion. Onion. Whoop, there goes the onion. Okay. I'm gonna have a fruit salad on the floor now. All right. Next is the pear. Pear is definitely disrupting the weight, like they're interacting with each other. And then lastly, the coconut. So the coconut weighs about 600 grams, so it weighs a little bit more than that half of the weight, and they're already like pretty severely interacting with each other. All right, so that's it for that. Now for another experiment that I wanted to do, I want to do what we did but backwards. So I'm going to put something that doesn't weigh very much in the middle. I'm going to put this aluminum foil ball in the middle. So you can see that the aluminum foil ball is not warping space-time because it doesn't weigh enough to warp space-time. So what I want to do is put something more massive in and see what happens. So if you're doing this at home, you know, like you should guess what happens because that's the most fun part. And let's see. So, whoop, there goes the coconut. So the coconut disrupted whatever was there first. So try this again. There. And I bet I can make it roll in towards the coconut. Yeah. So even if the coconut's on the other end of space-time, everything is drawn in towards it. Alright, so there's a bunch of different combinations of stuff you can play around with. That's pretty cool. But one last thing I wanted to try doing is I wanted to try to make some galaxies merge. And so galaxies usually have something really massive, and then they have a lot of dust and stars. So I found this glitter, which happens to be shaped like stars. I'm gonna spread that out. Try to spread out evenly. This is gonna make such a mess, but all right. So there's our stars. And I think we need some more because I have more glitter. So I can get this open easily. Oh, this doesn't want to come. Alright, so now we're going to test this. So this little marble thing weighs more than the glitter, but does it weigh enough to disrupt it is the question we want to ask. So we're just going to roll it through. And it doesn't really do anything. So we'll try this. Kind of dragged it along, but not really. We'll try the candy. No. Alright, we'll try the slime. Not really doing anything. So let's try something bigger. The potato weighs about the same, but let me see if I can figure out where my kiwi fruit got to. Alright, here's the kiwi fruit. I'm just going to roll the kiwi fruit down. So it's disrupting space-time a little, but it's not really doing that much. Maybe the tomatillo will do a better job. Let's see. Yep. No. Tomatillo is now covered in stars, though. Okay. So the next most massive thing I had was the orange. So we'll try to roll the orange. And the orange really doesn't disrupt space-time that much, so we need something heavier. Because the goal is to try to get all these stars disrupted instead of them just hanging out there. Whoop! There goes my onion. Okay, onion's not working. So let's try the pear. Alright, I'm going to cheat a little bit by shaking it because if I roll the pear around, and then it's disrupting them, it's collecting them, and it's making the stars, or the dust, or whatever you want to call it, a mass in one place. Alright, let's try the coconut. Haha, look at that. The coconut's really gathering them in. So if I roll anywhere I roll the coconut, it's kind of collecting the stars and bringing them all in one place, right? So I'm going to spread them out again because I want to try one more thing. I want to try to make two galaxies collide. And I'm going to use for my galaxies, I'm going to use the pear, and I'm going to use the onion. I have glitter all over my floor, but that's okay. Oops. And so we're going to go like this. And we're gonna, so if you are doing this at home, take your two things that are most alike in mass, I guess, and we're gonna try to spin them into each other. There goes the onion. Okay, So you can see they actually really disrupted these stars, and look, even though I had them evenly spread out, they brought all of this dust in together. So I want to try this one more time because this is my favorite part of this experiment. Go like this. Yeah, so they're dragging the stars everywhere. Okay, so that's my gravity demo. So these can be anything. So I like to think of them based on the mass. So I think that these guys can be like little planets. When I was doing it with the stars and the glitter, so if you think of like galaxies, kind of like, look, if you remember like pictures of the Milky Way or other galaxies, they usually have like this bright dust, and so that those glittery stars kind of worked as the bright dust. And so what happens if you imagine two galaxies merging, then when the central, like the massive objects merge into each other, they're going to drag all of their dust along with them. So that's what we recreated with that. But when you're using like the most massive stuff, that works really nicely as a black hole because the black holes will just drag everything in around them. And then the other thing I like about it is if you're using like the smaller things that don't weigh as much, you can see planets don't disrupt space-time as much that they'll, affect other things. So it all has to do with relative masses and size. So, anyway, that was my experiment. I hope you guys liked it. And if you have any questions, you can post them in the chat. Let me think about why I like gravity. So I don't appreciate gravity, like I feel like it gets me down sometimes. But I think it is kind of cool that everything in the universe that has mass is bound together by gravity. And a lot of the things we observe, we're directly observing the effects of gravity. So it's pretty cool. If you have questions, you can leave them in the chat and we'll get to them. But if you want to try this at home, you should definitely do it. I think it's really fun. So, and then the last thing is I wanted to tell you guys to come back next week because my friend Dr. Lara is going to be doing fluid dynamics experiments on Monday, the April 6th. And then if you come back 2 weeks from today, on April 13th, Dr. Shannon is going to be doing experiments with expansion of the universe. So thanks for joining, everybody.